Right, hello to you guys. Welcome to another exciting edition of Tenfold Live, which is proudly brought to you by Liberty. It is an honor for me to be with you on today's program. I'm very excited, guys, because we're actually getting the opportunity to be on Term 2. So we're going to get a chance to help you to understand what is important in Term 2 and some of the concepts that you guys need to worry about as far as Term 2 is concerned. So if you're a grade 10 learner, you're a grade 11 learner, you're a grade 12 learner, I'm actually welcoming all of you. Come closer, sit next to your screen with a pen and paper and probably a calculator as well, and run through the concept as I try and answer the questions that you people want us to look at. Remember, guys, if there is anyone you know who's currently not watching the show, let them know that they are missing the opportunity to multiply their content coverage tenfold and beyond. And we know that you guys have been trying on your own at home to do some self-study. Maybe teachers are helping you as well, sending you stuff via WhatsApp and those kinds of things. But then this is the only chance to have to see these things being demonstrated. You probably don't understand where certain things come from and you want clarity on those. Well, we are here for you. We are here for you to help you to understand how to work with them. So what you need to do is just go to your app. Go to your app, which is called WhatsApp, and then on your status, upload there. Tell people that Tenfold Live is up and running from 2 until 5 with this mathematics. So anyone who's struggling with any question that is related on functions and inverses, together with what we call the factor and remainder theorem, can send a question. We are accepting those and helping you to understand what do you need to do when you're working on those. So we're looking at functions as well as inverses, which is a concept you started from way back, in fact from grade 9 if I'm not mistaken, and then it became more serious when you got to grade 10, grade 11 as well as grade 12. That's where we're going to be looking at inverses. So I'm going to spend some time, maybe 5 minutes or so, just reminding you people some of the most important concepts that were built in grade 10 and grade 11, because this show is predominantly for grade 12. So, but it doesn't mean that if you're a grade 11 learner, you won't learn anything, because to be honest with you, over 60% of what is in your final exam paper comes straight from grade 11's work. So grade 11s, grade 12s, grade 10s, all of you, welcome. Welcome to the show. I hope you're going to enjoy what we'll be going through here, and you will understand how to work with functions as well as inverses. So I'm excited because I already have some of the questions that Mbali sent to me here that you guys sent to us via our Tenfold Education app, which is available on your app store. Some of you sent these questions via Facebook, so you might be the person that we are going through the question of. So you might be the one who's winning these great prizes that we have here. So stay tuned and make sure you don't miss any of what is going to be happening on today's show, because I promise you, you're going to learn a lot. Okay, cool. So the first question that I'm going to take here is one that comes from Gift Hyperbola. But before we go to that question, right, it's a very nice question. I am going to be a little bit interested in trying to help you build the content before we start answering the questions. Maybe spend 5 minutes or so reminding you those key topics that were introduced when you were in grade 11 as well as grade 10. Right. So let's pay attention to the following. We said we're going to be looking at our what we call functions and inverses, right? And the concept of functions is not new to you. It is something that you guys have looked at for a long time. And funny enough, this is the hardest topic for some odd reason that learners struggle with in paper 1. We know that in paper 2 you've got your problems there, but if you ask people what is the hardest topic in paper 1, they'll tell you that they don't like functions. So I hope at the end of this you'll be feeling much better about functions. So functions and inverses is what we will start with, and then later on we will then get a chance to focus on what we call the factor and remainder theorem that helps us to deal with polynomials. So what are the functions? Let's start here first of all. What are the functions that you guys know up to this point? We know that there are 4 functions that you worked on, such as a linear function is the first function that you guys looked at when you were in grade 10. Then you looked at what we call a quadratic function. It's another function that is definitely in your exams. And the other one that we looked at is a hyperbolic function. Very important for us to keep that in mind. And lastly, the function that you looked at is what we call an exponential function. So these are the functions that you guys need to know if you are a grade 11, a grade 12, or even a grade 10 learner. There's an extra one that you're going to look at for grade 12s, but we'll just limit them here for now, and we'll introduce it later as we progress with our lesson. Now, a linear function is what we also know as a straight line graph. It's what is also called a straight line graph. Some of you might know it as a straight line. The quadratic is what other people call a hyperbola, right? Funny names for grade 10s. They are very interesting. The hyperbolic function is probably not so popular, but some people call it a rational function. So if you hear people talking about rational functions, they're actually talking about a hyperbola, and the exponential function is an exponential function, right? So what is important as far as this graph is concerned? What is important is, of course, the shape of the graph. How does this thing look? Because a function is nothing but a relationship between variables, between two quantities, and sometimes it's more, but for high school, we only focus on relating two quantities. So a function is nothing else but a relationship between two quantities where for every input there is exactly one unique output, right? That is the technical definition of what a function is. But now we are not only interested in the words that describe those functions. We might also want you to know how do they look graphically. So these graphs that I wrote here, or these functions that I wrote here, graphically their graphs look as follows. By the way, a graph is just a picture of a function. So the graph of a linear graph looks like this, of a linear function. It's just a straight line that is either increasing or decreasing. For a quadratic, the shape of that graph looks somewhat like this. These are things that you guys know. They're very important, and we're going to be zooming in on them now. But it's very important for you to know how much you need to understand before you even worry about dealing with the technicalities of inverses and those kinds of things. And then a hyperbolic function has asymptotes, right? I'm not going to draw the Cartesian plane. I'll draw the asymptote of that graph and then maybe put that it has two curves that do not touch the asymptotes. They get closer and closer, but they never touch those asymptotes. And the last one, which is the exponential graph, right, also has an asymptote, but it has a single asymptote, right? And its graph looks something like that. It's increasing. Sometimes you get ones that are increasing. So this is how your functions look graphically. The picture of those functions is basically what you're looking at here. So what are the important things that you learned from grade 10 and grade 11 that are very, very key to assist you in grade 12? The ones that you need, the skills that you need to have in grade 12. They are things such as, number one, finding the defining equation. And I'm not going to actually talk more on these. If you guys need to know how to do this, just keep watching the shows. Even the follow-up shows will keep doing questions that will obviously involve finding the defining equations of each one of these beautiful graphs that we are looking at here. So finding the defining equation is very important, right? Defining the equation of each one of these. And if I may just spend some time, I'll remind you, like for a straight line, the defining equation is y is mx plus c, but I want to take the one that says a into x plus p plus q. And then for a hyperbola or a quadratic function, it is a into x plus p squared plus q. And then for that's for a quadratic function. Hyperbole is y is a over x plus p plus q. And exponential graphs can be defined as b multiplied by a to the power of x plus p plus q. Of course, it depends on who is teaching you or which textbook you're using. Some of those variables are not exactly as I am writing them, but these ones are the generally accepted variables that you use to define each one of those functions that you guys are looking at right now. Okay, cool. So if you know how to find the defining equation of each graph, the next thing that we worry about, that we want you to be good at, is sketching them, right? Because sometimes we don't draw these things for you, but we ask you to sketch these. Now, if you want to sketch these graphs, there are two methods of sketching these graphs. The first one is the one that you are introduced to when you are in grade 10, and it is what we call the table method. Table method is very simple because what happens is we just give you random x values, and then you substitute into the defining equation to find the corresponding y values, and then you just have your ordered pair coordinates, which you can then be able to successfully plot on a Cartesian plane, and then you'll be able to succeed to have the shape of that graph. This is where we normally say maybe -2, we give you -1, we give you 0, 1, and 2, and then you use whatever the equation that you're working with to find the corresponding y values, and then you can be able to plot these on a Cartesian plane and then get your graph, right? But then the one that I want you to be good at is what we call the dual intercept method, right? The dual intercept method, because the table method sometimes hides some of the key features of your graphs. The dual intercept method, right? The dual intercept method is what you people know as the method where we just say, if you are looking for the y-intercept, we're just simply going to let your x equal 0, And if you are looking for the x-intercept, what you simply do is you will then let your y be equal to 0. Of course, depending on which graph you're working with, you might need to do extra stuff such as finding either a turning point for the quadratic function or maybe finding the asymptotes, right, for either your hyperbola or the exponential graphs. These are just extra features depending on what graph you're working with, and you guys need to know which graph has got which features. So this is like just the general idea that you need to have as a grade 12 learner or as a grade 11 learner for you to have a fair shot at dealing with functions and their inverses without challenges. Now, the last thing that I want to draw to your attention beyond the whole story of sketching graphs is the third point, which is interpretation, right? When you have to interpret your graph, interpretation of your graph. This is where we're asking you things like, where is the graph increasing? Where is the graph decreasing? Where is it above 0? Where is it below 0? Where is the graph intersecting another graph? All those things that require your knowledge of algebra under interpretation. We might ask you, find x values where your graph is increasing, find x values where your graph is decreasing. What is the domain of the graph? What is the range of the graph? Remember, the domain refers to all the elements of the input, which means the domain refers to the x values, and then the range refers to all the y values that the graph does manage to cover. So all those things are what we call the interpretation features of your graph that you also need to be very good at, right? But the last thing that is important that I want you now to, particularly if you're a matriculant, right, is a concept that started in grade 9, which is the whole story of transformations on your graph, right? This is where the beauty begins. If you are a grade 12 learner, this is where now you need to pay more attention, because the transformations are not really news because you've been working with them since grade 9. They are grade 9 concepts, but now they come back under this whole concept of finding inverses of graphs, right? So under transformations, we did a couple of them. First of all, the transformation we did was the ones where we were talking about translations, right? When we were talking about translations, and your translations included shifts vertically and horizontally. When you were shifting or translating left, or when you are translating your graph to the right, then the affected variable from the defining equation is the p-value. And the other translation is when you are shifting your graph up or when you are shifting your graph down. And then the affected variable in that case becomes q, right? Very important for you to keep that in mind. And paying attention to the fact that the q value is actually the funny one. This one is the funny one because it actually does the opposite of what logic expects. For example, when you are shifting to the left, you have to add on the p-value. When you're shifting to the right, you have to subtract on the p-value. But for the one of q, you're up and down. When the graph is going up, you add on the q value. When the graph is going down, you will then subtract on the q value. So this is actually some of the things that you guys needed to know. The other transformation that you guys learned as far as graphs are concerned or functions are concerned was the whole story of reflections, right? And this is where the beauty of the whole story of inverses begins. The reflections. And we taught you about 3. There's a lot of things that you did, like including rotations from grade 9 and those kinds of things. But what is important for you as a grade 12 learner is, number 1, a reflection by the y-axis, right? The other one that you guys need to worry about is the whole story of a reflection by the x-axis, and lastly is the whole story of reflection, right, by the line y is equal to x, right? Now, how do you actually handle these kinds of reflections graphically? Well, if you have to reflect by the y-axis, what happens is everything stays the same, but your x will now change to be negative x. And if you are reflecting by the x-axis, what happens is your y will change and it will now be negative y, but everything else stays the same. And when you reflect by the line y equals to x, what happens is your coordinates swap, which means if you've got a point with the coordinates x and y, all your x's become y's and all your y's become x's. And this is where the whole story of inverse graphs begin, because this is the idea that the whole story of inverse graphs revolve around. So inverses are following this form of reflection, and we're going to be looking more at those as we go through the questions that you guys wanted us to look at. So this is essentially the most important things that are key that you guys need to know, the ideas that you have to have in your mind as far as working with functions and inverses is concerned. If I may go back just a little bit to remind you, because this is not news, it's what you've seen. You've got to know your graphs, each one, and the shape of each graph that you're working with. You need to know their names. You need to know how they look. You need to know the defining equation of each one of these graphs. And this is not news, it's what you guys have. If you can put all this information in a piece of paper, you will be able to understand how all this that you're looking at works in terms of answering exam questions. And then you've got to know how to find the defining equations. You've got to know how to sketch each one of them. And you obviously need to know how to interpret them. And then lastly, you need to understand the transformations that may occur in your graphs. Once you've got all this information, you are ready to start answering any of the questions that anyone might be having for you. So I think this is enough to give us the opportunity to start looking at the questions that you guys wanted us to look at. So I'm going to take the first question, which was sent to us by Gift Hyperbola. So Gift, thank you for sending your question through. You guys can also send questions either via inboxing us on the Mindset TV page on Facebook, or download our Tenfold education app. That's actually the best method, because if you click on the tutor option, you will see you'll get an opportunity to send questions directly, either in the form of video, or you can send a picture. You can even type it if you feel like it's not that long or it doesn't have any images. So let's go to this first question and see what the story was with it. So I'm going to try and draw it as I explain what is going on here. So this question reads as follows. It says here, the graph of f of x is equal to 2x squared plus 18, and g of x equals to ax squared plus bx plus c are sketched below. So we've got two graphs, and both of them are quadratic functions that are sketched here, right? They're very, very important, and we're going to try and draw them and help you to understand what are the key questions they might ask you, and how do you actually analyze these questions, right? So if I can just try to draw them. The first one is a set face parabola, right, which is concave down. And the other one, I'll draw it with a different color. It is a smiley face parabola, and it looks something like this, right? So that's actually what we have. You've got those two graphs. And now I'm going to draw the Cartesian plane. The Cartesian plane passes at this point here, which is point T, where the yellow graph is turning, and the green graph happens to also be passing through. So here's my ugly Cartesian plane, right? And then it also happens that at this point where the graphs intersect is actually where the x-axis happens to also be passing. So the Cartesian plane, I drew the Cartesian plane in white. This is the y-axis, obviously, and we've got the x-axis as the horizontal axis, right? We've got the origin there where these two intersect with each other, and there's key points that are on this sketch, which I'm now going to try and put here, right? So let me put the point in blue. There's point T here, which is the turning point of the yellow graph, which happens to also be a point on the green graph. And then on the far left, we've got point P there. And we also have got point Q, which is where these graphs intersect each other. There's also point R here. And the turning point of the green graph was given to us as point S. And these are the sets of information that was given to us. And the yellow graph is apparently named f of x, and the green graph is the graph of g. This one is the graph of g of x. Okay, cool. So what do we know so far as the love letter is concerned, right? Point P and Q are the x-intercepts of the graph of f. We can see them. And point Q and R are the x-intercepts of the G graph. S is the turning point of the graph of G. T is the y-intercept of both f as well as G, right? Now, we were given the equations of these graphs, but not complete. The graph of f is given to us as negative 2x squared plus 18. And the green graph is given to us as g of x equals to ax squared plus bx plus c. So we don't know the defining equation of this, and you can obviously predict that we might be required to find the defining equation of that. But we'll follow whatever Gift wanted us to assist with. Okay, so the first question says we need to write down the coordinates of t. Okay, cool. So now write down the coordinates of t. Write down the coordinates of t, right? Okay, I don't know what is happening there. Obviously, my technical difficulties there, but then we're going to go back to it. Let's go back. It's right there at the top. Ah, there we go. There we go. Yeah, okay, fine. We have to find, they say write down the coordinates of t. So when somebody asks you to write something down, it generally means that you don't need to calculate anything. Now, when you look at point T happens to be the turning point of the yellow graph, right? And you guys will remember, as far as grade 10, you were taught that the turning point of a graph that has got the equation ax squared plus q will always be 0, and whatever the q value is, it's actually 0 and q, right? So since we know that at that point there, from the yellow graph, the q value is 18. That 18 there is your q value. When your a is -2, your q value is 18. So which means the coordinate of point T will just be 0 as well as 18. And that's why they were saying write down instead of saying calculate. They were saying write down instead of calculate because you don't need to do any calculations. You just look at the defining equation. If you know your story, you will know that the turning point of this graph will always be 0 and q. If maybe this question is asked in grade 11 and maybe grade 11s want to compare this with the normal standard form, you would then need to rewrite this in the form a into x plus p squared plus q, because then the coordinates of the turning point will always be whatever this p value is here, which is -p, you take the negative version of that, and whatever this q value is here, they will always form the coordinates of the turning point. Now, if I wanted to change my graph of f of x to grade 11 format, I would rewrite it as f of x is -2 into x plus 0 squared plus 18. And you guys can see that the p value is 0 there, and the q value is 18, which will then constitute the coordinate of the turning point of our parabola. I hope that helps you to see what is going on, Gift. Right, the second question says to us here, we need to determine the coordinates of q. We need to determine the coordinates of q. Now, you guys struggle with easy things. I don't know why you struggle with easy things. So I'm going to show you the power of algebra in this. If you look at all the points on the x-axis, anywhere on the x-axis, I have something that I know about point P, point Q, and point R, right? If you're asking me to write what I know about all those points, I'll most certainly tell you that at point P, the y value is 0. We don't know what the x coordinate is, but we are very certain that the y value is 0. At point Q, again, we don't know what x is, but we are very certain that the y coordinate is 0. Even at point R, I don't know what the x coordinate is, but we know for a fact that the y coordinates are 0, because anywhere on the x-axis, all y values are going to be 0 all the time, right? Now, what I'm going to do is I'm going to apply algebra to solve that problem. They want me to find the coordinate of q. So the examiner is just interested in what is the x coordinate at point q, because we already know that the y coordinate is 0. So what I'm going to do is I'm going to take that 0 and substitute in the equation of the yellow graph, because I know everything about the yellow graph. That's what I'm sitting going to do here. I'm going to say we know that the graph of f of x is given to us as -2x squared plus 18, and you're looking for the coordinates of point q. That's what you're looking for. But we already know that its y value is 0. The y value at point q is 0. So it means for f of x, which can be expressed as y, is -2x squared plus 18, because that's what it is as good as that. My y can be written as 0, and I've got -2x squared plus 18. So what you're essentially doing is you are asking me to solve for x. And the whole problem changes from being a graph problem to being an algebra problem. And then the rest is just going to be adding 2x squared on both sides, which is going to give us 2x squared is 18. You divide both sides by 2, you get x squared is equal to 9. And then you take the square root on both sides, right? Now, what do our learners do? Our learners will just take the square root on both sides, and then they'll make a mistake. I just made a mistake there. I want you to pick it up. So x is equal to 3. And if you do this, then this means you made a mistake, because everything quadratic must produce 2 answers. So the mistake I made is I did not include a plus minus. So you guys have to be extra careful. Every time you take the square root, you need to put in the plus minus, because both +3 and -3 are solutions to this problem, right? Therefore, that means x is 3 or x is -3. So let's go back to the diagram and check which one of those two x values is relevant. If you go back, you check there, you will notice that this graph cuts the x-axis at 2 points. The yellow graph cuts the x-axis at point P and also at point Q. And point Q is on the right-hand side of the y-axis. That makes it to have a positive x value. This is then going to be positive 3. They didn't ask me, but I can just show how smart I am by also writing that at point P, the corresponding x coordinate is going to be negative 3. Right, and I hope this makes sense. And this is a very important idea. When you're working with these things, they are all stories. So number 1 helps you to work out number 2. Number 1 and number 2 will guide you to work number 3. That's how these things work. So if you're wise, whatever they ask you, after finding it, go and update your diagram. If you ask me to find the first question, I'm going to find the answer and then I'm going to go back to my drawing and update and write it there on the sketch. Because whatever I'm going to be asked following whatever I was asked before might depend on that first question. So you are actually enriching your diagram. You get to see that you know more because your eyes know more when they give information to your brain, since your brain understands pictures than memory, right? You deal better with pictures, with what you see, than what you have to remember. So instead of remembering what you found, put it on the sketch, put it on the drawing, so you can keep seeing it and you'll know that you know more, and then you can actually do more damage to the question as you follow up trying to answer whatever the next questions the examiners could be interested in. So I hope this is actually making sense. So I'm updating this information on my diagram and I proceed to the next question. Okay, the next question says to us that we are given that x is equals to 4.5 at point S, right? So 4.5 at point S, where's point S? We are told that at point S, its x coordinate is 4.5. So let me put it in point form, right? And I'm going to change now to green because I'm now interested in green, the graph that is green. Okay, this is apparently 4.5. Okay, cool. And then they say, you need to determine the coordinate of R. Okay, you want me to tell you what is the x coordinate at point R, because like I said, we already know that anywhere on the x-axis, all the y's are going to be 0. So you want me to find that. Okay, that's a beautiful question. Now, let's isolate the green graph so that this actually looks less messy for you guys. Right. So the green graph currently looks as follows. It's looking like this. It is passing through a couple of things that we know so far. We know that here it has got a value of 18 since it's sharing that y-intercept with the previous graph. We know that this is point Q. We already know its x-coordinate is positive 3, right? We know that here it is point R. We are interested in those coordinates of point R, and we know that it is turning at point S. And the examiner just told you that the x-coordinate is 4.5, right? Now, what you guys need to know is that the parabola is symmetric, which means the distance you travel from the turning point, when you're moving from this point here going to the left, the x-intercept on the left-hand side, that distance is equal to the distance moving from that 4.5 to point R. This is exactly in the middle. This is the middle of your graph, right? This is the middle. As a matter of fact, there's something that we call the axis of symmetry that divides your parabola into 2 equal pieces, and it passes exactly at the turning point. So if I know that the x coordinate at S is 4.5, I therefore know that the distance from 3 to 4.5 is just adding by 1.5, right? 3 plus 1.5 will lead me to 4.5. So I can then work out how much I need to add again to get to point R. It means you also need to add 1.5 to get to point R. And that is the easier way of finding whatever the x coordinate is going to be there. Now think about it. R, the x coordinate at R will just be 4.5 added with 1.5. And that should give you a value of exactly 6, which means then the x coordinate at point R is going to be 6, while the y coordinate at point R is going to be 0. If you wanted, you could have used the midpoint theorem because the turning point is always in the middle of the x-intercept. You could have just said the x coordinate of point S is the x at point Q plus the x at point R divided by 2, because the x coordinate of the turning point is always in the middle. Now, what is the x coordinate of point S? It is 4.5. The x at point Q is 3. We don't know what is the x of R. We need to divide that by 2. To undo division, you need to double on the right hand side and also double on the left. That will help you to remove your 2. You then have double of 4.5. That is going to give you 9. Is 3 plus x of R. And when you subtract 3 on both sides, you're going to get 6 as the x coordinate of point R. And that is another way you could have looked at finding the coordinates of R without any challenges. So I hope this helps you to understand 2 of the most important things about parabolas: how to find the defining equation of a graph, maybe how to draw it if it's drawn for you by finding the y-intercept, letting x be 0, x-intercept, and letting y to be 0. I hope this actually makes sense to you and you're feeling much, much better. Right. So let's go to the other part of this question that Gift wanted us to look at. So Gift wanted us to also look at what we call, what is this? Let's see what this story is. It is actually a hyperbola. So the graph reads as follows. The question reads as follows. It says, f of x is given to us as a over x plus p. Now this is what the second part of this graph, right? Plus q. Okay, cool. And now they say it has the following properties. They're giving you the properties of a hyperbola. You know for a fact, once you look at this, you know that we are dealing with a hyperbola. This is going to be a hyperbola. It's a follow-up question, which is not the same as the one that we just looked at. It's another one that was part of what Gift wanted us to look at. So thank you, Gift. Thank you very much. So this one says to us here, the properties of this graph. We are told the properties of this graph, right? Number one, the domain. We're told the domain of the graph. The domain of the graph is x is the element of real numbers, but x is not going to be equal to -2. We are also told that, what's this? The second part is that y equals to x plus 6, right, is the axis of symmetry of this graph, is the axis of symmetry of this graph. And we are also told that this function increases. This function increases for all x is the element of real numbers, except when x is -2, because of course it's not defined when x is -2. Okay, cool. Now they want us to draw this graph. Draw a neat graph of this function. Your sketch must include the asymptotes, if any. Right, your sketch must include asymptotes. So we have to draw this. That's what the question is all about, right? Draw this. Now, if you don't know how to draw a hyperbola, you are going to struggle in working with this question. You're going to struggle. And if you also don't know that a hyperbola has 2 axes of symmetry, you will also have problems working with this. So I hope, Gift, this is going to help you understand what is going on. So I must first of all start with the given part here, the domain story, the story about the domain. Now the domain gives you all acceptable x values. It gives you all acceptable x values that the graph will ever reach, right? And according to this question, this graph covers all x values except one value when x is -2. Now your mind should tell you immediately that asymptotes are lines or sets of points, right, where the graph will never reach. So in this case, since this graph will cover all x values except when x is -2, it then means that at x equals -2, we have our asymptotes, right? Very important. That's straightforward. Why would we say all x values are covered except -2? It means at x is -2, the graph is not defined. That definitely means that at x is -2, we have our asymptote. Okay, so let's upgrade our graph, right? Let's upgrade it here. F of x, I'm going to write it. There's f of x equals to, I don't know what a is, right? We are going to probably have an a value here, right? We've got x. Now, the x value that is not acceptable is -2. That means we need to have an x plus 2 here, because all the time when you're writing your asymptote is always going to be the negative version of that plus p that you have there. So you're going to have a problem when x is -2, so that when you look at this, it's going to cause a problem by division of 0. Because if I substitute -2, where there's x, I'm going to have division by 0. That's why the x value of -2 is not acceptable, right? We also need the q value here, the asymptote that is supposed to be here, the one we call the horizontal asymptote. We need to find that out. So the first part of the domain has just helped me to find the first asymptote of my graph. The second part says y is x plus 6. The whole story of y is x plus 6 is the axis of symmetry, right? How can this help me in this graph? Let's see why anybody would want to tell me that. Now, I've got a method that I use that you're probably not familiar with, right? I call it the banana method of finding the equation of the axis of symmetry, and I'm going to use it in this case. So you guys know that when you're looking for the axis of symmetry, there's 2 of them, right? Any hyperbola has got an asymptote, it has another asymptote, there's the axis of symmetry, the line that cuts the graph into 2 equal pieces. One of them increases like this. It has got the equation of y is x plus c. The other one is decreasing like that. It has got the equation of y is minus x plus c. And those cut both the curves of your axis of symmetry, irrespective of where your graphs are going to lie. Now, this is what you use when you're working with the axis of symmetry. Now, what I use what I call the banana method. Why? Because I just look at y is a over x plus p plus q to find both those equations. And what I do is I just isolate the a value like this, drawing a nice banana there like this, right? And then after I put this in brackets and I have got my plus minus, that always helps me to find my axis of symmetry, because I will then have y is plus x plus p plus q as my first asymptote. The other one is going to be y is minus x plus p plus q as my second asymptote. I use the axis of symmetry every time when they're asking me to work out the axis of symmetry, right? So this one is the increasing, the first one is the increasing axis of symmetry with a positive gradient, and the one on the right will be the decreasing axis of symmetry with a negative gradient, right? So then I would try and compare this with what was given to us. If you check what was given to us, we were given the axis of symmetry with a positive gradient of positive 1. So that means if you look at the top there, right at the top, my gradient is plus 1. So which means we are interested in working with this one here, the one on the left, right? So if I simplify what I have, I'm simply sitting with y is x plus p plus q. And we just found that our p value is 2. So this is y is equals to x plus 2 plus q, right? Now this must be compared with the given axis of symmetry. The given axis of symmetry is x plus 6. So let's compare them. We are comparing what I just wrote down with y is equals to x plus 6. What do you notice? Well, you notice that this part is the same, right? You also notice that this part here is the same. Therefore, this part needs to also be the same, which means we can then say 2 plus q must give you 6, right? Which means your q must come out as exactly 4. And that will help me to get my other asymptote, which is the asymptote on the y-axis, where q has to be equal to 4. So I'm going to go up, 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 and put my 4 here as the asymptote value for this part of the graph, right? Now, if I've got those, I don't really need to know what a is, because we don't have enough information to work out the value of a. And I'm just going to draw a rough sketch of this graph that has an asymptote at x is minus 2 because of that plus 2, and another x asymptote at 4. So that's really what I'm going to use to sketch my graph, and it's all thanks to my banana strategy here. All right, so my graph is going to look out. Here's your Cartesian plane, right? The first asymptote is going to be when x is minus 2, because the graph cannot pass at minus 2, and I'm going to draw it in a nice way. Let's get the asymptote kind of like shape. Right, okay, cool, right? It's going to be there. There's my first asymptote. Okay, the other asymptote is going to be when y is 4, so it's going to be somewhere there. And I'm going to try and label those. This is when x is negative 2. This is when y equals to 4. Right, a rough sketch. Doesn't have to be that nice. Okay, cool. And then they said the graph is increasing all the time. It is increasing all the time. So that means when you look at the graph from left to right, your graph has to be increasing, which means the pieces of our graph, or the curves of our graph, are going to lie in the second quadrant. They're going to lie in the second quadrant and the fourth quadrant of our asymptotes, right, of the Cartesian plane created by our asymptote. So which means one of them looks like this because it is increasing when you look at it from left to right, and the other one is somewhere like that. Now we don't care about where it's passing on the x-axis and the y-axis. We just needed to see the rough sketch of this so that we can have an idea of what is going on. As you draw it, it has to be increasing. You can see when you look at it from left to right, the graph is increasing for all x values except when x is minus 2. And then we don't really need to know what the a value is or what the intercept with these graphs are, because we were not given enough information to work out the value of a. But if we did, we could then apply the whole concept of for y-intercept, let x be 0, and for x-intercept, let y be 0. Now our algebra will then help us to figure out what is going on. So I hope this has helped us to recover a lot of basics from grade 11 as far as the quadratic function is concerned, and in addition as far as what we call a hyperbola is concerned. So thank you for sending in that question. We're coming back with a lot of very exciting content. You want to see where the whole story of inverse graphs comes from. You also want to see how to factorize polynomials of any degree.